Wait a minute. Oh, hello. Okay, so let's go ahead and get started with our examples where we're going to compare and contrast creating a closure decorator for a function versus creating a closure and using it as a decorator for a method that is defined inside of a class. So let's start off with our function first. Let's define a very simple function called sayIt. And sayIt just takes one argument called name, and it's going to print 40 dashes, and then it's going to print a formatted statement that says name is the best, and then print another 40 dashes. Okay, let's call the function and see it, make sure it works. We'll pass the name Phil. Okay, so that worked. It printed out the dashes and then the line Phil is the best. Okay, now I want to create a decorator for this function. And what the decorator is going to do is it's going to hijack the printout. It's going to change the name and it's going to print some other information. And so let's call our decorator decorate sayIt. So up here in above this, I'm going to define my decorator function def decorate sayIt, and I'm going to define that to take an argument name like that. Okay, so with our function, our decorator function defined, we're going to have two inner layers. The first inner layer is going to be our wrapper function, which is going to take the place of our original function in the code. So let's define wrapper. And at this level, we're going to pass the actual function sayIt. In this case, it'll be sayIt, but whatever function gets decorated with this decorator will get passed here as the argument. So type func. Okay, so that's our next layer. And now our inner layer is going to be where our processing takes place. And I'm just going to write this to generically handle any arguments or keyword arguments that are passed to the original function that gets decorated. And the way you do that is by passing star args and star quargs to that function. Okay, so we've got three layers to our function right here. And before I actually give this function any actual processing, I just want to print out a few things to demonstrate what is available inside of this closure in terms of the different variables and objects that would be available to it. Let's print out a few things. Let's print items available to decorator. Okay, and I'm going to print inside of that. Let's print the function that is getting passed to our decorator. Let's print out the value of any args being passed to the original function, and then let's print the value of name, which is getting passed when we actually use our decorator. Okay, so that for now, that's going to be the processing of our decorator function. So the first layer, inner, would normally return any result of the processing in the inner layer. In this case, all it's doing is printing, so let's just return none for now. And then the wrapper is the function that will get returned in place of our original decorated function. And so we want to return wrapper. So that returns the wrapper function, and that, let's see, return, oh sorry, we need to, I apologize, we need to return inner first. Wrong level. So return none, and then we need to return inner, and then we can return wrapper. Okay, so we've created a decorator function, and we've got our original function currently not decorated. I'm just going to run the code to make sure I don't get any errors. Okay, and so now let's go down here and let's use our decorator function to decorate this function. So at decorate sayIt, and let's pass a name which is Steve. Okay, So we've got original function, we're calling it passing Phil, but we're decorating the function and passing the name Steve. Let's run it and see what happens. Okay, so the instead of printing out Phil is the best, you can see that our decorator function changed the processing of say it, and it printed out these items that we've asked for. So if we look over here in the output, the items available to the decorator. So this first thing is the name of the function that got passed into our decorator function, which you can see is say it. So we know that the function itself actually got passed into the decorator function. The arguments that were part of the original function call, which in this case was the name Phil or the string Phil, you can see it's in this tuple of args. And then we also have access to the name that was passed when we decorated the function. We passed the string Steve into that line, and so we have access to that variable as well. So this gives you the idea of all the things that are available inside of the closure, inside of the scope of the closure that are available to use in processing. Okay, so let's go back to our decorator function and let's go ahead and add the functionality that we want our decorator to do. And what we want our decorator to do is we want to print out a message saying that whatever name was printed in the say it function is an imposter, and then we're actually going to print out the name Steve or whatever argument gets passed in the @decorate command as being the best. So here's what we're going to do. We're going to print a formatted string, and we're going to access the args inside of our formatted string like this, args, which is a tuple, and we're going to access the very first argument at index 0. Now that should be, in the case of the code we have, that should be the string Phil, because that was the argument that is passed to the say it function. So we're going to print out saying that Phil is an imposter. Okay. Then let's print, what we want to do is we want to print out Steve is the best. And the way we're going to do that is by calling the original function. Okay, so we're going to say result equals, and we're going to call the original function func, but now we're going to pass the variable name to it. So remember, name is the variable that is actually passed inside of our decorator here. So that should call the function say it, but it's going to pass the argument Steve in place of Phil. Okay, so there's that, and that should do it. And then we just need to change our return value here. Instead of returning none, we're going to return result. And let's go ahead and run the code and see what happens. Okay, so now that we have the decorated version of say it, you can see our output, it printed out Phil is an imposter, Steve is the best. So once again, I'm going to come back over here, I'm going to comment out our decorator so you see what the original function did. So comment this out, run the code. Okay, so you can see it prints out Phil is the best. But when it's decorated, it hijacks the functionality of say it and changes it so that it actually prints out Phil is an imposter, Steve is the best. Okay, so that's a pretty straightforward decorator function that we used by creating a closure to decorate this simple function with. Now let's go ahead and do the same thing, but instead of decorating a function, we're going to create a class with a method in it, and we're going to then decorate the class method. I'm going to show you the slight distinction in how you decorate it and what information, or excuse me, what code you need to add in order to make that work. So let's go ahead and create our class first. So we're going to define a class called test. Okay, and in test, let's define our constructor method. And the constructor method is just going to print 40 dashes. And it's also going to print, let's make it print a message that says a test object is created. Okay. And then let's define a method inside of our class. Let's call it identify. And identify, of course, the first argument will be self. And we're going to also have the argument name that will get passed to this method. And let's define self.name equal to name. And then when the identify method gets invoked, it will print a formatted message. Oops. That says, let's say it's going to say self.name created it. So it's going to say the name that gets passed in the for the method invocation, and say that that person created it. Okay. And then let's print another 40 dashes. Okay. So now let's test this out. Let's create an instance of the test class. So let's say x equals test, and then let's invoke or call the identify method. Identify, and we don't pass self here. We just pass the name, and let's stick with our same strategy. We're going to pass the name Phil. Okay, so let me just clear up my console here. And now let's run this code and see if we can see if it runs without error. Excuse me, missing the F here for the formatted string. Okay, let's try that again. There we go. A test object is created, and Phil created it. So we've got a very basic example of a method defined inside of a class, and it just prints out this simple message. So similar to what we did with our function, let's create a decorator that will decorate this method. And I'm just going to copy the code from our decorator that we used here, and then we'll just change a few words because the structure is going to be very similar. So let's just copy this code from our function decorator, and now we're going to just change a few things here. So first, let's call our decorator decorate identify, and decorate identify, and it will still take one argument, which is a name. And we've got our wrapper. Instead of a function, just to keep our nomenclature to differentiate between the two, rather than calling this a function or func, let's change the language to method. Okay, and so our wrapper takes the method rather than the function as the argument. Okay, so there's one other thing we need to change here, which is in our inner function, we need to add an argument to take into account that we're actually modifying or decorating a method. And when we decorate a method, which is defined inside of a class, we have to take into account that a method is not invoked on a class, but rather on an object. In other words, an instance of that class. So remember that class methods are applied to a particular instance of a class, and Python identifies that instance by implicitly passing the variable self when the method is invoked. So we have to take that variable into account when we decorate a method. In other words, we need to add the self argument to this inner function so that we're actually applying the function or the method to the proper instance. And so you can use the word self, but just to keep it distinct from using that word inside of class definitions, let's use the word instance. There's nothing special or magic about the word self. It's just a standard variable that is used in defining classes. And since we're not inside of a class, or we're not defining a class, but instead we're defining a function to be used as a decorator, let's use a different word other than self just to keep it straight. So we're going to use the term instance. Okay, so now when we actually call the function, so that instance, in other words, is getting passed to our inner function, and then we again we need to pass instance here inside of our inner function. So let's change this from func to method, and then let's pass again the instance variable. Now we also want to change the functionality a little bit here. Okay, so now we've got our decorator defined, and we ran it once before, and we got a test object is created. Phil created it. Now let's try running our code with our decorator, and let's go ahead and decorate our method. So we want to go down here above the definition of the identify method, And let's go ahead and put our decorator there, at decorate identify, and let's pass the name Steve into our decorator. All right, let's run this code and see what happens. Okay, so the code ran, and so if you look over here in my console, you can see that just like before, it printed out a test object is created, but it hijacked the original output of the method that printed out Phil created it, and it printed Phil is an imposter, which was a line of code that's defined inside of the inner function, and then it replaced Phil with Steve by calling the original method and passing Steve as the argument to it. So it printed out Steve created it. Okay, so let me just line these up side by side. So you can see that creating a decorator for a function and for a class method are very similar, with the only difference being that instead of a function, you're actually passing a method, or a method gets passed into the decorator function. And we have to make sure that we take account of the particular instance or the object itself that the method is being called on. So we have to pass that instance into our inner function as an argument here before our args and kwargs. And also when we invoke the method, we have to explicitly pass instance as an argument to that function. Okay, so just last thing, let's just review what each of these levels is doing. So the outer layer of our decorator, that's our decorator function. That's the definition of our decorator function. And when Python encounters the code that is the @ symbol with the name of the decorator function, it invokes that decorator function and it passes the function that is defined below it as an argument into that decorator function. It also passes any arguments to the decorator function call itself, and any arguments that ultimately get passed into the function when it is called will also get passed into the decorator function. So all of those things are available inside of the scope of the decorator function, which is the outermost layer of our decorator. The next layer, which is the wrapper, is the function that replaces the original decorated function. So the wrapper function gets returned back, and it serves as the stand-in for the decorated function. So the decorated function definition exists, but when it gets invoked, the wrapper function takes its place. Kind of like Invasion of the Body Snatchers, which is a movie about these aliens that came down and they replaced people with aliens, but they were replicated the original humans. You couldn't tell the difference except for they were aliens and they were evil. And so this is the same thing here. The wrapper function is sort of the alien. It takes the place of the original function and stands in for it. Then the next layer, the inner function, this is where all the action happens. This is where the original function will be called and any additional processing may occur. The result of the inner function gets returned back to the wrapper function, okay, and then the wrapper function itself gets returned to the decorator function, and that's how it stands in for the original decorated function. Okay, so hopefully this was a helpful example to show you the little nuance difference to decorating a function and decorating a method, and hopefully that helps you better understand the closure and the scope and the available items that are available to a closure inside of its local scope and how you use that.